Welcome to December 24th LeetCode Challenge. Merge intervals. Given an array of intervals where intervals at I is assigned to be the start at I and at I, merge all overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the input. So if you didn't get that, let's go for some examples. So example 1 here, we have an interval given here, and our output is here. See, this is one less. So basically, 1, 3, and 2, 6 are overlapping because 2 could be found within 1 and 3, and 3 could be found within 2 and 6. So therefore, we merge them together. It becomes 1 and 6. If we have another example, would be we have 1 and 4 and 4 and 5, right? 4 is overlapping in both of them, so we merge them together because 1 and 5. Because intervals 1 and 4 and 4 and 5 are considered to be overlapping. Let's look at our constraints here. We have interval length be 1 to 10 to the 4. Interval at I length is equal to 2. And start at n is between 0 to 10 to the 4, so we have no negative numbers. So the first thing we'll want to do is we're going to do a sort and merge algorithm basically, because it's not guaranteed that our intervals given is sorted. So two intervals I sub 1 and I sub 2 overlap if basically you know that so I'll just kind of go over the approach here, and so the best approach would be to sort the algorithm, sort the intervals first. So intervals dot sort using the internal sorting algorithm of Python. Output be assigned to the first index of our intervals. And this is what we're going to return. So this will allow us to iterate one by one and only compare the adjacent pairs intervals instead of every pair. Then we could just maintain a sorted list of and then merge and then insert new intervals one by one as we iterate through it. So let's do that. We're going to iterate through it. So for I in intervals, we're going to compare the answers together. So if interval and index at 0 is less than or equal to our output, this is the last index, just to say, then we are going to update output put at our last index to be the max. Output negative 1, 1, and I at 1. So basically, if it is overlapping, so basically if the index at what we have here is overlapping with our answer of our so for each index I we iterate through, we have I at index 0. If that's overlapping with our answer, then we want to find the max number within our interval output, between our output and interval, then we make that the output, and then we're going to return that as well. So else if this is already done, then we're going to basically append it to our output. Then we want to return output. Alright. Let's see. Let's run this code a bit. Since we have sorted interval, one condition is overlapping, it's already satisfied. We'll just sort afterwards. Okay, that looks somewhat promising. So we only need to check basically this part right here, which is our start interval. If it's less than or equal to the last interval of the sorted list is formed, then it's overlapping. Then we basically need to merge it together by taking the two intervals and updating the last interval sorted. If they don't overlap, we just append it. So let's submit it. Alright, there you go. Time complexity wise, it's a sorting algorithm, so we have n log n time complexity. The space complexity is basically it's a built-in sorting algorithm, so it's the space complexity of the sort, so we don't really count that. Alright, there you go. Have a great day, guys.